All right, so this interior angle, this tiny little sliver, is inside the triangle, and it's a 90-degree triangle. We want to use our x and y components, which is always going to be tan. So every single time you do a, doesn't even matter if it's bearing or quadrant bearing, anytime you're worrying about the direction of a vector, if you do this component method, you're always going to use tan every time. Okay, so tan of theta, we don't know the angle, it's going to be opposite. Y is our opposite of that angle. Y is, what are we doing here? Y is negative 0.1. We can kind of ignore the negative because that just tells us the direction. I can orient this triangle however I want. So we don't really worry about the signs here. When you're doing your angle calculation, you can just drop your negative signs over adjacent, which is 2.2. And so the negatives just kind of tell us that we're going backwards and then down. We can flip this triangle and make it look however we want. So it's going to give us the correct angle. Theta equals tan inverse of 0.1 over 2.2. So we should be expecting a pretty tiny angle here. If our diagram's to scale, which it's pretty closely to scale, this should be a relatively small angle. We get 2.6 degrees. Yeah, that's a very small angle. Doesn't look very good. Okay, so again, that's the little sliver in here. I want to know this arrow, right, from north to the red F1 vector, which means that it's almost all the way to 270, except it's this 2.6 degrees back from 270, ends us up at the F1 vector. So to finish the question and to get our bearing, we're going to do 270 subtract 2.6 degrees, which gives us bearing of 267.4 degrees. And that's it. So I should be back next class if you have any questions about this, but we'll continue on. Just remember that bonus assignment is due next class, and we should have your quizzes back by that class too.